So we continue. Our next presenter is Darko from AWS, and he will talk to us about infrastructure as a code. Hi, Darko.
Hello, Sergey. Hi.
Tell us a couple of things about yourself. Who are you? What was your path to where you are now?
Okay, sure. Well, first of all, thank you for having me here. It's the first time I have a chance to speak to the folks from Novosibirsk, so I'm very honored to do so. I've been working at AWS for the last 5 years. Been started off in premium support. Basically, I was helping the AWS customers over the phone and chat all those wonderful technical problems you need to solve. Moved on to solution architecture, and now I'm a developer advocate. And my job is to talk to developers, engineers, folks who use AWS, use the cloud, such as yourselves, and try to entertain and educate and also be your voice within AWS. I originally come from Serbia, so I can understand most things you're saying, and I can read fairly well Russian. So.
Well, that's cool. That's cool. And I know an interesting fact about you. You collect old computers, right? So tell me a couple of things about why you do this. And this is super.
Yeah, I think this is mostly due to the fact that as a young kid, I've basically grown up on old computers until 2001. My only computer that I've used was a Commodore 64. So until 2001, then I finally got a new computer, which was a 486. So I always have this passion for old computers and old things. If you can see in the corner of here, this is an old Amiga monitor right now, sitting on top of a Pentium 1 PC. I have a IBM X60 here, and I have a whole lot of things here. I'm just a big fan of old esoteric computers because I think I like the diversity in computers that used to be a long time ago.
Wow, cool. Where do you store them all?
Mostly in my room. I actually have a whole bunch of them still in Serbia because I started off my collection back then, and moving them all from Serbia to Germany is a bit of a problem. I store them within my room. I have them a bunch of my shelves. I have them in like a whole set of them here next to me. So yeah, it's becoming a problem. At one point, I will need to have a specific storeroom for old computers, but I have not reached that point yet. So, and as we speak, I'm waiting for an old Sun Spark server to arrive. So, looking forward to that.
Well, and to our main topic, question to you. The approach of infrastructure as a code that is growing very fast right now, what do you think? How long will it take to become the standard and for you not to have to talk about it to anyone?
I think it's. I wouldn't be able to say like a timeline, but I think anybody who's doing anything on the cloud now, no matter which cloud you're using, right? No matter which system you're using out there, if you're doing something on the cloud, you should be using infrastructure as code because it's not because it's cool, it's not because it's the thing to do, it's because it's more easy to you, right? It makes your life that much easier. So I think that in the coming years, especially everybody who's switching over to the cloud and to those kind of services is going to absolutely drop the clicking and adopt the keyboard a bit more. So hence you can use an old computer to do all the stuff.
Wow, thanks for your replies, and I think we can go to your presentation. You have the floor.
Oh, thank you very much, Sergey. Okay, I even have a timer. Perfect. Hi and welcome to my talk on the topic of infrastructure is code. This is very important for us to say because yes, absolutely, any type of infrastructure that you do on the cloud is code. It's an API call. It's something that's being provisioned for you. Basically, it's software-defined data center, I believe it was the term a long time ago, but now we like to call it infrastructure as code. And today I'm going to go through a bunch of other things, answer what is, or basically why infrastructure as code. I'm going to talk about a few offerings on AWS, or actually few approaches to infrastructure as code on AWS, and some other tools out there that can help you build out your AWS infrastructure through the lovely means of using a keyboard. And on top of that, I'm going to talk about some best practices from my experience and from experience of others on how to implement and how and when to do infrastructure as code. Let's answer the first question. This is the most important question. Now, I came here assuming that not all of you are using infrastructure as code. So I'm going to be explaining what this is. And if you already know, feel free to check your email right now. So let's actually step back in time. Long ago, 10 years ago, I used to work in a company where I was a thing called a server provisioning administrator. And my job was to deploy things like this. Deploy servers, deploy operating systems on servers, and it was an American company. I was based in Europe, and basically I would have somebody rack and stack my servers, and I would install lovely operating systems on them. So I would have call a guy in Fairbanks, Alaska, and tell him, hey, my project requires 500 physical servers. Can you make sure they're racked and stacked? Okay. 1 month later, he calls me, they're all racked and stacked. Okay. Please give me a list of IP addresses. Oh, you have to speak to this other guy. He will get you the IP addresses. Okay. He gets me all the IP addresses. Then I load up your favorite Java-based remote administration utility, mount your Red Hat 4 ISO, and go ahead and install Red Hat 500 times. It took a few months to finish that. If I would ask you right now, how long does it take to do this in the cloud? Exactly. So, well, actually, you know what? Let's do this. So, behold my terminal. What I'm going to do right now is I'm going to deploy a serverless application in 3 different regions, in Ireland, in Japan, and in California, with a single command line. So, CDK deploy Ireland, Japan, California, stack. I'm going to be doing, what is it? There is a command that you can run. Let me just find it. It is the require approval, -- require approval, never, and bam. Is this good? This is good. Okay, it's deploying now. We'll come back to this in a moment. So, it takes much less time and effort to do that on the cloud, as you see me right now. So in the cloud, infrastructure no longer is a bunch of cables. Well, it still is, but you don't treat it as such. It's more this. It's code. It's basically defining what you want, what you need, and how you wish it to be configured through code. So why infrastructure as code? Why do we write our infrastructure in these text files, templates, or whatever you would like to call them, and provision them as such? Well, it gives you the ability to have a predictable and repeatable infrastructure, right? When you make changes, you will actually see what kind of change you will make. You will be able to repeat that numerous amount of time, because no matter how often you click, there's a chance that you forgot something, there's a chance that you misclicked, and by codifying all of these things, it makes it that much more better. It also gives you the ability to actually deploy infrastructure changes through the same tool set, same pipeline, same everything you have as you would deploy other software, which is very important, right? Why would I have to reinvent the wheel in deploying infrastructure? Because it's software at the end. Let me use my same CI/CD pipeline for that. And on top of that, if you ever had to deploy, if you ever had to copy production to development or staging, I had to do that manually in my lifetime. Like, oh, can you just make a copy of production into development, and it's never the same. Yeah, it's so easy to do it if you already have it defined as a template. You just change a bunch of parameters and bam, you have a staging environment. But you may be screaming at me like, oh, Darko, well, this is nothing new. I use scripting languages, I use PowerShell, I use Python to use your SDK and create your infrastructure. Absolutely. And that's what brings me to 2 types of infrastructure as code. There is the imperative. Basically, I tell you what to do. I call an API. I directly invoke an API saying, hey, create me an S3 bucket and do it this way. Versus declarative, which is hey, I need an S3 bucket. You figure it out. You are not calling an API. You're telling a framework, hey, listen, I need an S3 bucket. I need a container. This container needs to be configured like that. It needs to be configured like that. These are the properties I wish to be set. And then you let it go, as the song says, and let the framework behind you do all that job for you. And declarative is kind of a better approach right now than doing imperative, because imperative, you need to handle idempotency, you need to handle all of those complicated things. All right, so I've already had a really nice intro, but you also may be wondering, why am I screaming at the camera? And maybe you would like to hear more. Well, hey, absolutely, that's me. Wow, there you go. My name is Darko Meszaros. As you can see, I come from Serbia, a bunch of different types of spelling of my names. You may recognize a few. I do sort of understand Russian. If you speak slowly enough, I can understand you. I speak Czech and Slovak and Serbian, so a combination of a bunch of Slavic languages makes me understand Russian as well. I've had a massive... in the last 8 years, I've actually changed 5 countries. So from Serbia to Czech Republic to Malta to Ireland, and now living in Berlin, Germany. And if you want to hear more of this person here, if you want more bald goodness, make sure to check out the social medias and the YouTubes and the Twitches, because I do a lot of content on YouTube. I do Twitch streaming. So if you're interested in technology, in AWS and all those things, join me for some videos there as well, because, hey, we only have 40 minutes today. All right, let's check in with our infrastructure as code. All right, still deploying. It's going there, but hey, it took me a single command. Let's give it away. Okay, Japan is deployed. We're just waiting for California to deploy. All right, let's go back. Let's talk about the OG infrastructure as code framework on AWS, which is AWS Cloudformation. Now, AWS Cloudformation is the infrastructure as code service. When I joined AWS 5 years ago, this was the only thing we were using that back then. I think Terraform existed back then still, but Cloudformation was the thing that I was using. So this is a really nice way to basically provision resources on AWS through things called stacks or templates. Basically, you use either YAML or JSON. Well, use YAML, please, to create templates, and these templates contain resources, and those resources are basically modeled where you say, hey, I want an S3 bucket, or in this case, I want a code commit repository, and I want to give it this name. I want to give it this description. You kind of define these things in lovely YAML. Well, lovely YAML. Let's not get into that. And basically, it can create over 490 resources on AWS. Well, actually, it can create any number of resources anywhere right now, but I may be getting into that later on. So it's simple as that. You define your templates. Now, templates can be complex. Templates can have parameters, can have metadata, can have mappings, condition, resources, which is the main thing. I mean, the only thing your template needs is the resources. Everything else is just fluff. But you can create, mappings, parameters. Of course, you should create parameters so you can make your template a bit more agnostic by changing what you launch depending on what parameter you pass it on. You can also have some conditions, some very bare bones conditions. They're not super flexible, but they exist there, right? There's a few examples out there. And also because this is code. Okay, okay. Let me bring this up. YAML and JSON are not programming languages, but it's still code. You can do things with CloudFormation code, right? You can put it to a pipeline. You can apply testing. You can have linting and unit testing, and you can actually deploy this code to a testing environment to see, does it actually work? So you can apply all the best practices to software delivery, to your infrastructure delivery, because again, infrastructure is code. But hey, again, you may say, Darko, I use resources outside of AWS. Not everything is on AWS. You are correct, sir. You are absolutely correct. And this is why the lovely folks at Cloudformation built AWS Cloudformation Registry, which is a really nice open approach to managing external resources. In essence, this gives you the ability to create your own custom resource. Now, I will not have the chance to show that off today, but in one of my older talks, I've actually built like a small custom resource that invokes my own API. So basically, I have an API somewhere that creates unicorns, right? Of course, and the CloudFormation custom resource basically can invoke that API to create unicorns, and basically that unicorn is now a CloudFormation resource. So no matter where you think, you can basically invoke a VMware API to launch a VMware instance somewhere locally. You can use Azure. You can do GCP. Basically, you can now model to launch anything you need. And this is especially useful for folks like our ISVs, independent software vendors like Atlassian, Datadog, and Spotinst, where they have built their own custom resources. So, hey, you want an Ops Genie user? Absolutely, you can have a custom resource that creates an Ops Genie user for you with Cloudformation. Now, the year is 2020, right? Things are like containers are amazing, right? We have EC2 instances, we have clusters, we have all those things. But what is the hot thing in 2020 or for the last few years? Serverless, right? So does Cloudformation do serverless? Absolutely it does. Is it complex to do it in serverless? Absolutely it is. So that's why we've kind of tried to make it a bit better, right? Trying to remove the heavy lifting of complex serverless applications from Cloudformation, and we've created Cloudformation's little brother, SAM, or the Serverless Application Model. SAM is a framework that basically is built on top of Cloudformation. In essence, it is Cloudformation. It's just a transformation on top of it. It makes creating certain serverless applications much easier, right? So it kind of abstracts a lot of things. It's a macro per se, right? It's great. It's just not just that. It has a lot of different things. It has a CLI. You can do some local testing. But let's actually have a look at some SAM code, because this is how much it takes to create a simple serverless application. So with 20 lines of code, you can create a Lambda function, an IAM role, an API gateway, and actually on the bottom, if you see the simple my simple table, that is a DynamoDB table. So, of course, you can do all of this in Cloudformation, absolutely, but it will take you much more than just 20 lines, because you have to define specific Lambda functions and API gateways, then specific IAM roles and attach it. SAM kind of abstracts all that for you, so you can purely focus on modeling your serverless application and just let it go. Now, SAM has CLI, which, as any good tool out there, you need a CLI. So SAM CLI is a lovely tool that basically enables you to create, build, test, and deploy your SAM applications. I mean, of course, you can deploy that. That's all fun. But the biggest part of SAM CLI is the ability to test Lambda functions locally. Because if you were like me and you're like, so serverless functions run in the cloud, how will I troubleshoot my serverless functions if I am on an airplane, if I have no internet? Well, SAM can actually do that. With the power of Docker, it can actually emulate your Lambda functions and API gateways locally on your workstation to make it work. So how does SAM CLI work? Well, you install it using pip or brew or I believe Chocolatey for Windows. You can install the AWS SAM CLI, a lovely tool. It exists. To create a SAM application, SAM init, just create an application, give it a runtime, give it a name, all that stuff. And then you can do that big thing, which is the ability to actually run SAM local. Now, SAM local is this local testing of your Lambda functions. Basically, you create an event. An event is just a JSON file that says, hey, pass these things onto my Lambda function. You create an event, you run SAM local, invoke with a specific event, and then it will run the Lambda function locally on your workstation, just like that. So it is very cool. And on top of that, SAM local and all these abilities actually give you the chance to debug your serverless application. So you can actually, if you're used to like step through debugging in your IDE, like you open up your JetBrains or VS Code and you like to make a breakpoint and see what's in the memory of a certain piece of code, you can absolutely do that with Lambda right now, thanks to SAM CLI, because SAM CLI and AWS Toolkit for those IDEs basically enable you to do all of those things. So it's not just all the cloud. On top of that, you can have the other things, the parts of like validating your templates, the building, the packaging, and actually deploying your templates or your SAM or serverless SAM applications, actually. So, and these things are cool. Yeah, you can run them from your workstation, but ideally you would take these things and plug them into Jenkins or plug them into Code Pipeline, put these things into your CI process. So, and this is usually how people do that. Few more bells and whistles regarding SAM. SAM has this lovely function called SAM logs, which basically enables you to stream logs from a certain function locally. Basically, it will tail logs on your workstation directly from a Lambda function running in the cloud. So amazing. For troubleshooting something that's running there, instead of going to CloudWatch and trying to refresh that button to see if it works, just perfect. And for the fans of serverless application repositories, which is our repository where you can with your serverless applications, I guess, you can actually publish your SAM applications directly to SAR and have it available via SAR to all of your customers within your AWS account. So pretty cool. Oh, local tests. The thing I explained, I actually have a demo or a recorded demo. But before we get into this, I just want to check out on this thing. Oh boy, it's deployed. So right now, if I would be doing this again, one of the things you can see, I have 3 stacks deployed globally. So it says deploying, but it's no changes, no changes, no changes. You will see that I have Ireland, Japan, California, and this global table stack deployed across the globe. And they're actually different regions, different things. So if I would be basically let me copy this thing like that, and I can do HTTP, wabam. I should be getting a missing authentication token because I need to say hello. I should be getting, this is a hello from AP Northeast 1. This is a hello from Tokyo. So yeah, basically deployed an application globally within just a few minutes. And I'm proud of that. But speaking of something to be proud of, local tests. Let's actually have a look at a pre-recorded thing, how SAM does local tests. So this is my SAM, or actually this was my SAM thing. It was in May, as you can see. It was a long time ago. But if I click on this, you will see my SAM application. It's a super simple SAM application that has just a simple event. It's just a single function, nothing else, no JS function, no API gateways, nothing. It's a hello world function basically that takes an event. It takes a name basically from an event and says hello that name, right? So I'm going to now create an event, or actually I'm going to show you an event that basically does that. The event just passes in a name. You see that it's passing a name called Alan Ford, and it's going to pass the name on to the Lambda function by using SAM local. So I'm basically invoking a local function right now that says, hey, hello world, that's the function name. And you can see that it's invoking that with that event. So it's going to be basically running it in container and going to be outputting hello world with all the logs and everything else we need for our Lambda function. And yeah, that was all run on my workstation a few months ago. But yeah, that gives you the ability to do all of these things, which is pretty neat. Now, let's actually move away from SAM and move away from CloudFormation because there's some other thing. I like to call this CloudFormation's uncle or some relative cousin or something like that. It is the AWS Cloud Development Kit, or CDK. Now, if you have never heard of CDK or Cloud Development Kit, you may be wondering why more. I mean, CloudFormation, it's nice. We have SAM for serverless. That's just amazing. Well, maybe you're like me and you're kind of ticked off by JSON, by having to read JSON. Mind you, when I joined AWS, it was only JSON. So writing a complex template in JSON should not be written. JSON should be read, and that's it. Actually, JSON should be consumed by other APIs and computers and programs. JSON should not be read and written by people by hand. And also maybe YAML ain't your thing. Right? YAML and tabs and all the lovely stuff is special, to say the least. Maybe you're just a god in Python. Maybe you have the biggest knowledge in Python. You can do everything in Python. You build amazing applications. You build amazing platforms and workloads and whatnot in Python. Why not use Python? Or why not use other generic programming languages to build your infrastructure? Why do you have to go and use YAML or JSON, which are not bad, don't get me wrong, but they have their own place? Well, you can. With AWS CDK, you can actually use Python, TypeScript, JavaScript, Java, C#, F#, and also Golang coming quite soon, hopefully. You can use these languages to provision and build your infrastructure. So basically use the existing knowledge that you have in-house, use the power of these generic programming languages to enable your developers, and also use the community who is quite growing out there when it comes to CDK. So it is quite powerful to do this. Like, again, it's a generic programming language. You can use all the bells and whistles, reading off disks, importing modules, doing more complex conditional logic in it. Basically anything can be done. Well, okay, okay, wait. Basically anything can be done with CDK. So again, this is a really neat way to do all of these things. And just to say one thing here, CDK is not anything revolutionary here. CDK is actually using Cloudformation. So we have not went ahead and just built everything from the ground up and like, okay, well, we're going to make a whole new framework because that's what we do. We built a framework that's going to be using Cloudformation to deploy your things. CDK is just here to actually translate the language you write into Cloudformation and then let Cloudformation do its all. So you basically write these things called constructs, or that's your source code, where you create applications or apps, and those apps contain stacks, and those stacks contain resources. Then the magic of the CDK CLI, see, it has a CLI, basically takes all of that, converts it into Cloudformation templates, and just lets Cloudformation do that. The thing you've seen me do, right, this is all CDK, but I'll get into that in a moment. So we let Cloudformation actually handle all of those things. So yeah, amazing. And Cloudformation does it really, really good. So how is this kind of split up? CDK constructs, the piece of code you write. There are 3 types of constructs you can write. And this is very important for you to know. There are the normal Cloudformation constructs. Basically, they're a copy-paste of Cloudformation. Anything that Cloudformation supports is supported on CDK Cloudformation constructs. So trust me, everything that Cloudformation can do, CDK can do as well. There's the service constructs. These are the highly opinionated, well, not highly opinionated. These are constructs with sensible defaults. So if you create a VPC as a service construct, it will create a VPC with 6 subnets, each one per availability zone, and private and public and all those bells and whistles. If you create a VPC in Cloudformation construct, it will just create a blank VPC, nothing else. And when we talk design patterns, this is where we get into the well-architected and highly opinionated way to do things. For example, I have a pattern that creates an application load-balanced Fargate service. So we launch our containers in the cloud with using ECS and Fargate. We can do it with 4 lines of code. Those 4 lines of code, actually, it's technically 3 lines of code, right? I am not counting the squiggly brackets. These 3 lines of code will actually generate 817 lines of Cloudformation code with all these services, right? So it gives you the ability to do all of those things. Amazing. If you want to of course you can add parameters. It's not just a single solution. There's ways to modify this, but it gives you the ability to launch something really, really quick. And the thing that sold me on Cloudformation is just the ability to create a VPC with a single line. Not Cloudformation, CDK. So if you ever created a VPC on Cloudformation, if you wanted to do a full multi-subnet, private public VPC, it takes you like 100 lines of YAML or even more with JSON. With CDK, it takes you 1 line, which is just amazing. On top of that, because it's a generic programming languages, you have all the testing out there. You can do all the testing. Every language. Well, currently I think it's only supported on JavaScript or TypeScript, but you can use things like Jest, right? You can use like Jest unit testing framework for JavaScript to actually test your CDK code with the means of like snapshot tests, using fine-grained assertions, and even doing generic programming validation tests. So all of this kind of brings up the game in your infrastructure code. But okay, it's not just Cloudformation. It's not just SAM. It's not just CDK. We all know who we're talking about right now. There's more things out there. Yes, there's Terraform. Terraform is lovely. Terraform has an amazing syntax. It's almost JSON, but better, right? So it's JSON with all the good things. Terraform is a framework, again, a third-party framework that allows you to deploy infrastructure on AWS, on other vendors. It basically can do all the things, right? I think you can even deploy like configurations to like network switches or something like that. So Terraform is quite powerful when it comes to those things. But actually, Terraform loves CDK. The folks from HashiCorp actually built a CDK version or CDK plugin or a CDK CLI version for Terraform. You can actually go ahead and install CDK TF CLI, which in essence gives you the ability to write Cloudformation code in, I think currently it's supported, not Cloudformation, CDK code, which is currently supported in JavaScript, TypeScript, and Python. You can write CDK in those languages and have it produce Terraform. So if you wanted to use CDK to deploy things to even Azure, right, you can actually do that with some CDK plus Terraform. So that's just amazing. I'm a big fan of that. This is a simple example that I've done it with my colleague. We created a simple VPC, I think, on a subnet and an instance and all that stuff. It looks very much like Terraform, but it is still JavaScript or TypeScript in this case, and creates all of those things. And it supports Serverless, apparently. So as you can see in the name of the instance. All right, let's move on. Let's slowly wrapping up point, right? I think, how am I on time? Let me have a look. Ooh, I have time. Okay, we'll do a demo as well, something. We'll look at some of the code I've showed you before. So let's first of all talk about best practices. It's important that we understand what are some of the best practices when it comes to infrastructure as code. And some of these are very straightforward. You already know this. You will tell me, why are you saying me this? This is normal. Trust me, it's important to say. Number one, layer your infrastructure. Do not put all of your eggs in one basket. Do not create a big old template that does it all. It's very important to create multiple isolated, separate stacks depending on what they do, and basically just communicate between them through outputs and exports and whatever way you need to kind of produce different things. The example I've showed you creates 4 stacks. One is a database stack, and 3 are serverless application stacks, which are basically being deployed globally on a different region, right? So do those things. It's going to make it easier to make changes. But very important. Oh my God, this is a quote from a colleague of mine. Do not keep your persistent data and everything else in the same stack, because if you delete it, your persistent data is gone, and you do not want to delete your persistent data. So keep persistent data in a separate stack. Start small. Do not try to boil the ocean. Do not try to go ahead and I'm going to just spend a month rewriting my entire infrastructure in a template and then try it. Start small. Move little things. Try to see if it works. Do not try to specify every little bit of detail as you get on, because you make it a bit more complicated, right? Also, it's okay to repeat yourself. Do not try to over-engineer things, right? Do not go ahead and construct complete set of libraries and constructs just because you don't want to type something twice. It's fine to type it twice sometime. It's less effort. It's not essential that you create a construct or a library just so you can reuse it twice. So make sure to do it, because over-engineering things makes it much more difficult in the long run. And quotes such as this, right? Especially the second quote, keep in mind the operational aspects of it. If you make infrastructure over-engineered, super complex, you know who's going to knock at your door? Operations. Operations is going to come and scream at you why did you make it so complex? I know it's fine. We're engineers, right? We love to make things elaborate. Sometimes you don't have to. It's okay. Best practices number 4. Use parameters, use mappings. Try to make your templates as agnostic as possible. In a sense, try to make them reusable, right? Have a single template that can be used in production, development, and staging by just changing a couple of parameters, right? Use store secrets in systems manager parameter store, or secrets manager, or HashiCorp over Vault, or whatever secret management utility you're using. Keep those things away from your template. Yes, do not hard code sensitive information into your templates. Please, I've seen people put passwords and secret keys and all the things into templates because it's easy and it's in my private repository. Don't. And Amazon, if I try to write a file and try to commit it to Git, no matter which Git, and that thing contains something that looks like a secret key of AWS, it will prevent me of doing so. So do not do that, no matter if it's a private repo. Put your secret somewhere else. You don't want it to be visible. And lastly, test. There's so many tools out there. There's so many ways you can kind of put in guidelines and guardrails to kind of prevent things from going bad. The same you do with software, do with infrastructure, because infrastructure is code. May I say that again, right? So make sure that somebody looks at your code, like peer reviews. That's why we use repositories. We make a pull request to our infrastructure, see if it's good. If it's bad, we don't let it through, right? Because at the end of the day, automation makes it easy, so much easy to screw up things at scale. So be careful about that. Make sure not to mess up at scale, right? All right. Let me have a look at the time. I think, oh, perfect. We have some time. Actually, let's go ahead and look at some code. So you've seen me demonstrate the big old global deployment. Let's actually have a look at what this is. So this is my my CDK project that I've done for a different talk. It's basically a way of deploying a global application on with serverless, or a global serverless application with CDK. Let's actually see what it holds. So if I go to app.py, wait. This is Windows, and Windows for some reason doesn't like my Vim. 1 second. Bam. Come on, Vim, show up, please. Oh, boo. There we go. Okay, so what do we have here? We have here a bunch of things. Okay, install the lint, that's fine. Thank you. So we have a bunch of things here. We are actually creating 4 different stacks, as I said before. We have our database stack. This stack basically creates a global DynamoDB table. Now, I'm not going to get into what that is, but it's a DynamoDB table with tables across the world, right? Then I have regional stacks. Basically, these are the same thing. This is the same code deployed across 3 different regions. So we have a stack going to Ireland, we have a stack going into Japan, and then we have a stack going into California, right? And it's, if you can see here, it's the same. It's the same. It's the same stack. It's the same, basically the same piece of code that's being deployed across multiple different regions, right? Let's actually have a look at that code. So if I go here and go to stack, right, this is the main stack. This is the serverless application stack. And again, this is CDK written in Python. CDK supports multiple languages, and it looks mostly the same in any other language. I choose Python because I like Python. So I'm importing a table. This table has been created with the previous stack. So it imports the table from a parameter that's being passed on to the stack. Then I'm also importing a Route 53 zone. Now this zone, the DNS zone, has already been created a long time ago because you don't want DNS to mess up your demo. So I create my DNS zone a long time ago. I'm basically just importing the zone from this current account. I'm even creating a certificate. So creating a certificate, a free certificate on AWS, a validated certificate, it takes 4 lines of code to do that. It does a whole lot of magic in the backend where it creates a certificate and validates it with DNS because you own the domain, whole lot of things, but it does all of that for you. And finally, there are 2 functions here. There's the hello function, basically the one which says hello, right? And there's a function for health check. Now, I have not implemented health checks here per se, but I basically created a /health Lambda function that will just say okay to 200. All right, it will never be unhealthy unless I tell it to be. It's a demo, right? And then finally, I have an API gateway here that I'm saying, hey, create an API gateway. This is going to be your domain name. This is going to be your certificate, and integrate both hello and health applications, or actually create 2 resources, hello and health, and then integrate those Lambda functions to that API gateway, and then add the get methods to your API. And last but not least, you need to set up some permissions. And again, as with a lot of things, a single line just gives you the ability to create a read and write permission to your DynamoDB table that you have imported to your function. Simple as that. So yeah, this thing is super simple. I'm sorry. It's super simple if you do it enough, right? It might seem complex now, but this thing, if you want to check it out, is available on GitHub. So if I would be going, where is that thing? Come on, where is, I had it open somewhere. Yes, here. So github.com, and I think I may be sharing the link with you, GitHub. Not GitHub, but going global with serverless. So basically my GitHub page, Darko-Meszaros, going global with serverless. You can find this entire code here. Again, it's being used for a talk I did this week, but it's a very useful thing to check it out. So let's actually change something here. So let's go to Lambda and let's change the hello function to say, instead of this is a hello, this is something else. Now, this is Zdravo. Zdravo is the way we say hello in Serbian. I'm not sure if this would work. Will JSON be able to do that? But let's actually try it out. So if I do CDK deploy, let's just deploy to Ireland, right? Deploy Ireland stack. I'm going to deploy the change to a single Lambda function right now to my to my Irish stack. So what it does now, it creates a CloudFormation change set. It creates basically a change set that's going to be used for CloudFormation to apply these changes. And the only change here is just replacing that single Lambda function, nothing else, because everything else has not been changed. So we're only changing a Lambda function. We're going to be changing that code there. Of course, this should all be in like a pipeline. I should have just done a git commit, and it should all went through a pipeline. But hey, for demo purposes, this should demonstrate more, I guess. So, and if we go back here and go to CloudFormation, you will see that my Ireland stack is currently in update in progress. And we will see here that there's been a update in progress, and one of the resources that's going to change is going to be one of these functions here. So if I go back here, we'll see, okay, it has been finishing, update cleanup in progress. There we go, perfect. It has been deployed. Now, the question here is, how does Lambda handle Cyrillic in its responses? So hello, HTTP, and then let's do that, and then do hello. This is a Zdravo from EU West 1. Okay, it works. Perfect. So you've been able to see me deploy some Cyrillic into my Lambda functions. Okay, cool. Let's go back to the presentation and a couple takeaways. Get into infrastructure as code early. It's important that even if you're doing things in a little tiny scale, if it's creating a single EC2 instance, a bucket, auto-scaling group, even just a single serverless application, do it through infrastructure as code. It's going to make your life easier in the long run. I've said this many times, but treat infrastructure as code as any other code out there. It will make it much, much better for you, right? All the pipelines, all the testing you want. And finally, use the best tool that fits your needs, because there's so many frameworks, so many tools out there that exist and are just amazing, right? So the question is, okay, Darko, so should I use tool A or tool B? Yes, you should. Use the one that's best for you, because the old saying goes, the best programming language is the one you know. Thank you very much. I hope you enjoyed this presentation. I've loved delivering it, and I hope you learned something as well. Oh, I guess I will be able to answer some questions right now. Maybe, or not. Or do I have to entertain you for the next 2.5 minutes? I can, until the folks come back. Should I be entertaining? Make sure to follow me on the Twitters and the YouTubes and and LinkedIn and all this stuff. Again, I try, oh, there's a, oh, thank you. Thank you, Sergey.
Darko, thank you indeed for your presentation. You're probably the most charismatic presenter today.
Thank you.
The question. We know that AWS provides us with a huge amount of possibilities.
Right.
But for some, it's a little bit of a vendor lock. So what are the tools that you can use with this approach without using the AWS?
Well, so I mentioned Terraform. Terraform gives you the ability to deploy infrastructure in multiple different cloud vendors. Again, when we discuss the term vendor lock, I think it's a very loaded term. Vendor lock is more of it's the cost of transition. So no matter what your tool you're using, you're still decided to use a single tool, right? Or a single tool that will help you use something else. So absolutely, if you want to completely avoid AWS or AWS tooling for this, you can go for CDK, which supports Terraform, and you can do Terraform. There's also Pulumi out there, and there is also, well, I don't know of any big ones out there besides Terraform, Pulumi, and CDK for Terraform. So those would be my options if you wish to not use, if you're not running on AWS and you wish to deploy things to different cloud vendors.